Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling Podcast with Chuck Bowser, RCDD. Well, seeing how we're pulling Category 6A, the most powerful twisted pair in the world, you gotta ask yourself this one question. Did I pull 295 or 300 feet? Well, do you feel lucky? Do you, punk? What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. The elite professional, knowledgeable, and experienced in leading-edge ICT design principles. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Wednesday night, 6 p.m. Eastern Standard Time. You know, that only means one thing. Live after hours with Chuck Bowser, RCDD, your favorite RCDD. Shout it out loud. Be proud. Say, Chuck is my favorite RCDD. Go ahead and say it. Be proud of it. Proud of it. Yes. So let's get on with the show. You know, we always start off with, what are you drinking? So put in the comments what you're drinking. Some areas it's after hours, some of the area it's not. Chuck is drinking water with lime essential oil. George says he's not drinking anything. Big Daddy's drinking mountains. You mean Mountain Dew? Now, I love my water without lime or lemon or lime essential oil. You might be wondering why I'm putting it in there. About 2 years ago, I had kidney stones. And boy, I tell you what, you want to talk about pain. Oof. Oh my gosh, I don't ever want to go through that again. Ever go through that again. And it helps when you bring the microphone in front of your face. Whoops. Not like I've done a video before, 345 videos and counting. Right. The doctor told me that if I wanted to avoid kidney stones in the future, make sure that I had always had a little bit of lime juice or lemon juice because it helps the kidney stones from forming. So that's why I always put it in there. I don't always put it in there, but I love water without it. Oh, by the way, don't forget to my QR code is not in here, is it? Dang it, man. I really got to get my game together, man. What is up with that? Oh, you know what? I deleted it out for something. That's why. Okay. So yeah, we're always looking for support. So make sure you look up go to my profile, go to the Linktree account where you can send me money, help support the podcast. If you're a firm believer in this podcast, you get enjoyment out of this podcast, you get learning out of this podcast, please consider supporting it. You know, I don't say it enough, but I'm still paying the vast majority of the costs for this podcast out of my pocket. And I need to change that. I do. I really, really do. So, yeah, consider doing it. Consider becoming a Patreon member. Consider maybe even scheduling a 15-minute one-on-one call with me after hours, of course. Or you can go to my Amazon link page on my webpage and look at tools and stuff. And if you buy something, I get a small stipend off it. You don't pay any extra for it, but I get a small stipend for that. This week, the acronym challenge. This is a good one. I bet you very few people will get this one. Now, this acronym challenge, the acronym is ETA. ETA. That's the acronym for this week. And it's not estimated time of arrival. Okay. This week was a holiday week. We had Labor Day on Monday. And Labor Day holiday is attributed to its origins from the unions. So this week, all of the podcast acronym challenges are union oriented. So the acronym for today is ETA. ETA. What does ETA mean? Let me know. Let me see. Put you in the chat box. Nobody's guessing in the chat box. Man, right? Linktree. Yes. Exactly. Link tr.ee/ let's talk cabling. Thank you, Mr. George. I appreciate you. So, what does that acronym mean? ETA. I'll give you a hint. The first letter, the E, stands for, ready for this? Electrical. Electrical. So now you just got to figure out the T and the A. Electrical what? Anybody got some guesses there? Going once, going twice, going three times. ETA, Electrical Training Alliance. Electrical Training Alliance. In case you don't know who they are, they used to be known as the NJATC, right? The National Joint Apprenticeship and Training Council, which started over 70 years ago as a partnership between NECA, the National Electrical Contractors Association, and the IBEW, the International Brotherhood of Electrical Workers. And their goal was pretty simple, basically to train the best electrical workers in the industry. Fast forward today, what are they doing? The Electrical Training Alliance has grown into the largest apprenticeship and training program of its kind. And through their local affiliate programs, they've helped over 350,000 apprentices reach their journeyman status. That's what the ETA is. That's what the ETA does. Now, I don't want you thinking, oh my gosh, Chuck's a union guy. I like the union. There's nothing wrong with the union. I've worked for the union for a short period of time, and I haven't worked for the union. So I've been a non-union worker and a union worker. There's benefits and drawbacks to both. Actually, one of the posts that got the most tracks this week was, should an electrician do low voltage cabling? Oh boy, did that stir up some dust. That stirred up some dust. Hey, did you notice no podcast episode came out on Monday? Yep. I have podcasts recorded in the can, ready to go. But I felt that, we just got back from camping on Monday, and we didn't get back until the afternoon. And I was like, it's a holiday and celebration of Labor Day. Not going to do a post. So there was no post last Monday. We'll pick back up on next Monday. Oh, that also reminds me. Next Monday's live stream. It's going to be really cool. I've got a guest coming on, and we're going to talk about which is better, commercial cable installers or residential cable installers. Yeah. Put your answer in the chat box. Which do you think is better, commercial or residential installers? And make sure you tune in next Wednesday night at 6 p.m. with my special guest as we debate which one is better. Right. So let's get on with the questions. The first question is, Chuck, what is a big mistake you see installers make when setting up a structured cabling system job? Okay, there's about 4 or 5 things, but they are. Somebody says they're both different skill sets. There are different skill sets between the two, but a lot of it overlaps as well. So, getting back to what is the biggest mistake you see in installer training? The biggest one I see, lack of planning. Actually, I'm putting out a list of 7 project management pro tips this week. So it'll be coming across LinkedIn and all the other social medias over the next few days. So lack of planning. So many installers, they jump right into the installation without looking at the design, without looking at the layout, without talking to the estimator or maybe the person who sold it. Right? There's a lot of things going. Plan. Right? Plan. Another thing that causes a lot of problems is ignoring standards. Right? Funny thing is there's a good part of the industry that do follow the ANSI and the TIA standards and the BICSI best practices, right? But there's also a large part of the audience that they think they can do better. Here's the thing about the standards and the best practices. They are written by industry professionals who have decades of experience, and they're ways to do the thing correctly, efficiently, and without least amount of pain. And they put that information, they put all of their learning in a book to keep you from making the same mistakes. That's why I'm a big proponent of the standards. I'm a big proponent of the Bixby best practices because it already, and these aren't here for show. These are not here for show. You can see they are tabbed out. I use them all the time, especially in class when people ask me questions. Follow the standards. By following the standards, you're going to guarantee that cable plant's going to perform the way it's supposed to perform. That's the best thing I could say. Even if you're not required to follow the standards, because technically the standards are voluntary. The only time you really have to follow the standards is if it gets contractually obligated. It's written in the contract that your work will meet and exceed the standards. Then you have to follow them. Or sometimes you might have a customer that might, or your company might say all of our work must follow the standards. But follow the standards. Another area that I see causing problems is improper cable management. Improper cable management. Like not paying attention to the bends, letting the cable get kinked, improper support. If you see a cable, let me flip back over so I can see the camera. If you see a cable that has like a white line in it like that, see if I can get that to focus. See that white line? See the white line in there on my TikTok peeps? That means this cable has been overstressed. And there's a problem right there now. Right? That's what happens when you do those kinds of things. So you got to make sure that you don't exceed the bend radiuses, don't exceed the pull tensions. Make sure you put the supports in the correct way. Another one too is I see people have problems, big mistake, is skipping the testing. Skipping the testing. And this is another one of those things that starts a huge debate in our industry. Do you certify or do you not certify? And some people say, absolutely, I certify every drop. Other people say, no, I only certify when the customer pays me. I will pound on wood and say this. Set the dogs off. Oops. I will say this until there's no breath in my lungs. You should be certifying every drop every time you install it, right? Scandalous on the TikTok feed says every drop, 10,000 points to use Scandalous, 10,000 points, my friend. Now we can have a conversation on whether or not you sell those results to the customer. That's a good conversation to have. But as a professional, you should be certifying every drop. That's just, as Ed the old tech guy would say, that's the birth record of the cable. So if anything happens to that cable later on, you've got proof that it worked fine and dandy on this day when you finished the project. And here's another big mistake I see installers making. Inadequate labeling. Yes, they don't label it, or they don't follow the standards to label it, or they don't use a machine-generated label. Those are the big three mistakes with labeling. And I don't understand why people don't label by the standards, because it's so easy. I need to make a video on this. Oh, hold on. Every time I do these live streams, I always come up with an idea. So, video on labeling. And this will work really well because I'm working on the podcast studio, and I can show that when I actually move the rack up there. Somebody asked in the TikTok feed, how's the anti-static flooring going? We were camping last week, so it hasn't really moved, but I'm going to try to get some done this weekend. Yeah, make sure everything's labeled. And because that not only saves you time on doing the job, especially when you're trying to test the cables, that's going to save the customer time when they go to cross connect. That's going to save the service tech time. Inadequate labeling. Big problem. Big problem. Next question. How do you determine the right cable pathway in a commercial installation? Okay. There's some good things here, right? So what you really need to do is, if before you go out on the job site, if you have access to the architectural drawings, make sure that you look at them. Look at the electrical drawings. Look at the HVAC drawings. Look at the fire sprinkler drawings. See where all that stuff's going to be in the ceiling, and that way you can plan your route to avoid those structural issues. So what happens is every time you come to a duct, you got to go up and over that duct. you are adding to the length of the cable that was not put in the bid. Be prepared though, because as soon as you get out to the job site, you better verify those routes, because I guarantee you site conditions have changed. Site conditions have changed. You also want to consider scalability. If you follow the standards, this sets you up perfectly, because the ANSI standard tells us we have to run 2 cables to every work area outlet, 1 for voice, 1 for data. And it further tells us that when you're designing the support structures, the J-hook, the ladder rack, the cable tray, you need to design for a minimum of 3 cables for every faceplate. So what that does is it builds in about a 33% growth rate in your pathway, because the average lifespan of a structured cable plant is about 7 to 10 years. Now, that doesn't mean cable goes bad in 7 years. It just means there's always new technology coming out and stuff moving on. I mean, I know some cables out there, like all they're being used for is like for fax machines. They've been there for 30 years, right? 30 years. But when you're looking at, network cabling connected to computers, and especially now with building automation, single pair Ethernet, power over Ethernet, more and more cables being installed. But Chuck, copper's dead. Fiber. I just started getting back into Reddit and started going through those posts and stuff, and just kind of interjecting myself in those conversations and stuff. And I can't believe how many times somebody says, no, just run fiber. Fiber's not the answer to everything. Don't get me wrong, fiber is better than copper, but it's not always the answer. Not always the answer. So when you're looking at those pathways, you also, one of the reasons you want to avoid electrical is you want to avoid interference from EMI and RFI, electromagnetic interference, radio frequency interference. And you want to maintain distance. Now, if you go by the standard says minimum of 12 inches of separation. If you have to cross electrical, cross that at 90. Okay. There are some scenarios where you can get closer to that, but you need to know the amperage of that circuit and the number of devices on that circuit, which typically you don't. So if you follow the 12-inch separation and the 90 degrees, that's going to help you for 95% of stuff. Because here's what will happen, and this is another reason why you want to certify. If you just do a continuity test and that cable's a bundle of cables laying on top of a fluorescent light fixture, you'll get continuity, but it may not pass that certification test. That's another reason why you should be certified. Right? And when you're putting in a path, when you're looking for how that pathway put it, make sure that you choose a pathway that's going to allow easy access for the cables today and tomorrow. Okay, today and tomorrow. Again, if you follow the standards, it sets it out for you automatically. It tells us that the pathway's got to be at least 6 inches above the tile. Code says 3. Standard says 6. And then the standard calls out for a certain amount of space above the ladder rack as well. Right? I want to say it's 12 inches, but I'm not sure. I have to go back and check that stat. I don't know if it's 6 or 12 above it. And that's so you can get above the cable to pull the cable in. So when you're looking at your pathways, make sure that it's not, if you've got one hallway where there's very little room and another hallway where there's a lot of room, take the one with a lot of room. That way you've got room to get above the ladder rack or the J-hooks to be able to put the cable in there. Of course, as always, make sure that whatever pathway you choose, whatever support system you use, that it follows the NEC and also ANSI and the Bixby guidelines. Right? Number 3. What is the come back. There you go. What is the maximum cable length for horizontal run and why? This is another one of those areas that causes a lot of confusion in our industry. Now, let's talk about the standard limits. The standards. Look, Shotzi's in the house. Shotzi, how you doing, my friend? Just but verify, as Phil likes to say. Absolutely. And then we also have ZD Atkinson, the 4th, certifying or testing every time. Yes, you should certify every cable every time. That's absolutely you should. Right. Sorry, I missed 2 weeks. I have you on my calendar now. Very good. Not a problem. Hey, like I said, since you guys kind of came in late, make sure you don't miss next week's, because I gotta show who's better, commercial or residential dollars. Yeah, it's gonna be one. going to be a good one. So let's get back to the cable length. First, let's talk about what the standard says. So when you talk about the standards, it doesn't matter if it's Cat 5e, Cat 6, Cat 6a, the maximum length is 90 meters or 295 feet for a permanent link. Permanent link is the cable that goes from the connector on the faceplate to the termination in the telecom room on the horizontal cross connect. That could be a port on a patch panel. That could be a landing spot on the 110 block. Okay, 295 feet. That's the maximum, because that allows for 10 meters or 33 feet in patch cords to be put on the ends of those. 100 meters. And the reason for that is because of how Ethernet works, right? Number one, it's going to ensure that that signal integrity and performance for high-speed data systems works. Because what happens is, I just taught a class today when we talked about this. When you're typing on a computer, you're creating ones and zeros. And those ones and zeros come down through the layers of the OSI model. When it gets to layer 1, the physical layer, the transmitter puts those into a packet. It puts a start bit on it, puts a stop bit on it, and then it sends that signal down the cable. Now, the reason for the start and stop bit is because that tells the receiver, hey, start listening, got a message for you. When that signal gets to the receiver takes off the start bit, takes off the stop bit. It's left with the ones and the zeros, and it sends that to the layer 2. And then the receiver sends a signal back to the transmitter. I got it, send the next one. When the transmitter hears that confirmation, then it knows it can send the second packet. By the way, that's called asynchronous transmission. There's also a synchronous transmission. Synchronous transmission is different. It doesn't have a start and stop bit. So that signal has to go from the transmitter to the receiver, be processed, and the confirmation's got to be sent back to the transmitter within 570 nanoseconds, give or take. It depends on the frequency, but 570 is a good average. So that's why we're limited that 295 feet. Right? And but here's a tip: the better you keep that cable, the better condition you keep that cable, the better that signal is going to be, and you might actually even go a little bit past that 295. If that cable is as pristine as it was when it came from the factory, you might still get a pass going beyond that 295. Not too much further. It's not like game changer cable that can go 400 feet, 500 feet, 600 feet, but it can't go past it if you keep that cable pristine. Right? Keep that pristine. Now, the effects of longer runs. So that's the standard answer, right? That's the standard answer. Take care, Kaylin. There are some scenarios. So Cat 5e and Cat 6 both do 1 gig. Cat 6a can do up to 10 gig. Cat A can do 40 gig. Okay, up to that 295 feet. Cat A, I'm sorry, can only go 30 meters. Cat 5e can do 10 gig. Did you hear me? I didn't say Cat 6. I said Cat 5e can do 10 gig. There's a fellow content creator, Mike Pinocchi. He's a trainer for Fluke Trainers. I follow his social media stuff. And he did a video just a couple weeks ago in his house that he had a bit error rate tester, and he threw it on there on a Cat 5e cable in his house, and he successfully ran 10 gig across it. Now, it wasn't 295 feet. That's not going to work. If memory serves me right, I want to say it's probably 100 feet, maybe a little bit less than 100 feet. So you can go faster than the 1 gig for Cat 5e and Cat 6. Cat 6 can do 10 gig up to, 55 meters, 60 meters, something like that. So in reality, sometimes you can go a little bit faster, but you can't go the extent. But if you follow the standards, then your cable plan is going to work 99% of the time. Right? 99% of the time. Now, when it comes to fiber, dude, fiber, it's the best cable we have. You can go much longer distance without signal loss. And there are scenarios where you can go, 1,000 feet, 5,000 feet, 10,000. Single mode fiber, if you're transmitting just, for example, like telephone stuff, 50 miles. 50 miles. Yeah. And that's why some people, when they learn about fiber and stuff, that's why they kind of, everything's fiber. I hate that. How long does a marginal pass tested cable last? Great question, Luke. Great question. So let me first talk about what is a marginal pass test result. So when you test the cable with a certifier, there's preset limits in the testers that are set by the ANSI standards. So the engineers at the manufacturers put those limits in the cable, right? Well, the tester, if you get a test result that's within the accuracy of the tester, you'll get a star on it. And a lot of people refer to that as star pass or star fail. What that means is that the cable, the tester, not the cable, doesn't know if it's technically a pass or a fail. It's within the accuracy limits of the test, right? And so what does that mean is it could be a pass, could be a fail. Now, the question asked by Luke was, how long does that marginal pass last? So the marginal pass, if you get the marginal pass and you're still able to put your data across 1 gig, 2.5 gig, 5 gig, whatever, as long as nothing happens to that cable, it doesn't get wet, it doesn't get damaged by somebody putting something in later on, it should last fine. It should work fine for years, right? Because you tested it at that certain time. Now, again, if somebody pulls cable in the bundle and they damage that cable, puts a kink in it or whatever, now you might have problems where it might start failing. So that's a great question, Luke. 10,000 points to you, my friend. 10,000 points. Yes. Yes. Okay. Question number 4. How do you handle a situation where the original design needs to change because of unforeseen issue sites? Sorry. Can't talk tonight for some reason. Excuse me. It's called a change order. Change order. You're welcome, my friend. You're welcome. It's called a change order. So it always happens, and here's the thing. Change orders can come from, a site on the condition changed from the original estimate. Like you went out there and you decide you're going to use this hallway, but now you can't use it because other trades have used it. Or it might be a change because a customer came to you and said, look, I want to run, instead of running Cat 5, you're going to run Cat 6. So the first thing you need to do a site assessment, right? You need to look at how is that specific change going to impact the project, both labor and material. And and schedule. Yes, and schedule. There's the project manager coming out of me, right? You always look at those 3 things. Once you got a good feeling for what those things are, then you need to confer with the design team. Go back and talk to the estimator or the project manager. Always communicate. Hopefully they're an RCDD, Registered Communications Distribution Designer, right? And talk about them. Say, look, here's the site conditions. They've changed. I know you told me to go down this hallway, but I can't because they're running big electrical feeder cables down that hallway, and that's going to cause me problems. And then that way you and the RCDD or the project manager or the estimator can talk about the best way to do those changes. Now, once you've got that figured out, what it's going to cost, time, material, and impact the schedule, then you need to document those changes. So document them. And then what you need to do is present that to the customer. Present it to the customer and get them to sign off on it before you do the work. Okay. Never do work on a change order without having a signed document in place first, right? Always. Because once you do the work, if you don't get the change order signed first, you lose all your leverage. I have done projects where we've done change orders and we had the change orders signed before we did the work and the customer still skirted it and got around it. That's right. They didn't pay for it. So if you get the change order signed before you do the work, there's a better chance that you're going to get paid to do the work. Still doesn't guarantee that you're going to get paid to do that work, right? Mirrorbar69 on TikTok says, a furniture group cut my cables, brand new installs. Ooh, that sucks. What would I do in that scenario? Again, it kind of goes back to what we just talked about. First, site assessment. How am I going to fix this? How much is it going to cost me to run new cabling? How much material am I going to need? How much labor am I going to need? And here's the thing. And by that point, when they're putting in furniture, Mary Barr, when they're putting in the furniture, the ceiling tiles are probably in place. There's furniture everywhere. There's people walking around. It's going to be harder to do the job than when it was new construction. So it's going to take more time. And obviously, this late at the stage where they're putting in modular furniture, it's going to impact the schedule. So get all that information together, right? And then in your scenario, what you need to do is you need to go to the customer and say, look, the furniture contractor cut our cables. Our cables aren't supposed to be spliced. And then you and the customer together go after the modular furniture manufacturer for what's called a back charge. Back charge. That means you actually bill the vendor, the trade that damaged your cable to pay for it. The customer doesn't pay for it. Now, sometimes I have had this happen. I've had customers say, I'll pay the change order to get it fixed because we don't have time to argue this now because we got a moving date in a week. I'll pay it now, and then I will go after the modular furniture people. I've had that happen. I hope that helped you, Maribar. Let me know if it didn't. Okay. All righty. We are at 6:31. I'm 1 minute past, and it's already dark out here. So I got to go put the animals away. So let's cut this one short. Well, we're not cutting it short, but it is what it is. So until next time, everybody, remember, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.